Good morning, dear students. Welcome back to our online class. In last class, we have discussed about the laws of refraction, okay, and refractive index, the ratio of the speed of light in vacuum to the speed of light in a given medium. Okay, some numerical problems are given in your book, in exercise. Okay, so you will try to solve those numericals, okay, on the basis of the formula mu. Refractive index mu is equal to V1 upon V2 RC by V. Okay, clear? Later we will discuss some numerical problems based on this formula. But first we will discuss today refraction through rectangular glass slab. Rectangular glass slab. Okay, how refraction takes place through a rectangular glass slab. Suppose, see here, this is a rectangular glass slab. Okay, so it is in 3D form. Okay, I will show you later. Okay, the device rectangular glass slab. Okay, here rectangular glass slab. Wait. So here in dry normal. Okay, here this is the normal incident point P. This is the rectangular glass slab. Rectangular glass slab about A, B, C, D. Thickness of this slab. Thickness. Suppose T. Thickness is T because it is in 3D form, na? Like this. It is in 3D form. 3D figure, na? So this is thickness. Thickness of this glass slab is T. Length and width L and B. Thickness, you can say that height. Length and width L and B. Okay, clear? So here, if we light ray coming from the source, strike on this incident point. Incident ray. Make an angle with the normal angle of incident I1. Okay, I1. Then, since it is a rarer medium and this is the denser, this is the denser medium, rarer and denser medium. Okay, clear? So it will bend towards the normal. Bends towards the normal. This is the angle, what? R1. Angle of reflection R1, and this is the refracted ray. Refracted ray for that point of incident. So first time here refraction takes place, then again here light ray entered to the rarer medium. Again light ray here entered to the rarer medium, means air. So again here refraction takes place. So we have to draw one more normal. Here normal. So this is the, now here this is the, it becomes incident ray and this is the angle of incident. This is the angle of incident. Suppose this is the angle of incident, here I2. Okay, this is the I2. Now again this is normal and suppose this is M. So here light ray travels from denser to rarer medium. So after reflection takes place, it will go away from the normal. Here in case of rarer to denser medium, the light ray bends towards the normal, but in this case light ray go away from the normal. Go away from the normal. See. Light ray go away from the normal. Refracted ray. Here it behaves like a reflected ray, but for this medium it is incident. Finally, it is called, when it's coming out from the glass to the mirror medium, finally it is called emergent ray. What? Emergent ray. Finally, it is called emergent ray. Clear? Okay? This is the emergent point. This is the emergent ray. Okay? Clear? This emergent ray is parallel to the initial incident ray. That is the initial, if we will proceed this ray forward together. Okay? So this is the parallel to the what? This initial incident ray. And the perpendicular distance between this emergent ray and initial incident ray. Initial incident ray. This is D. Okay, this is the perpendicular distance between the initial incident ray and the emergent ray. This D. Okay, lateral displacement. It is called lateral displacement. Perpendicular. If we draw the perpendicular to this line D. Here, suppose this is O and this is P. So OT is D. That is what? Lateral displacement. Lateral displacement. Okay, clear? So when the light ray, in the case of glass slab, when the light ray insert from rarer to denser medium, so it will bend towards normal, and again it will come out from denser to rarer medium. So it will bends away from the normal, and in case of when the light ray insert from rarer to denser medium, it will bend towards normal, and the light ray when coming out from denser to rarer medium, it goes away from the normal. It goes away from the normal. Clear? So finally, this is called emergent ray. This is called emergent ray, and this is called angle of emergent. Angle of emergent. Finally, this is called angle of emergent I. Angle of emergent. Angle of emergent I. Clear? So for this ratio, sine angle I1 by sine I1 by sine R1, and here sine I2 by sine I is always constant. Is always constant. Okay? Clear? According to the Snell's law of reflections. Okay? The ratio of the sine angle of incident medium to the sine angle of reflecting medium is always constant. Same as here also. You can follow this rule. It's always constant. Clear? Okay? So, in this way, the light ray when passes through from rarer to denser medium, then denser to again rarer medium, through the rectangular glass slab. Finally, the emergent ray becomes parallel to the initial incident ray. Clear? This is the perpendicular distance between initial incident ray and emergent ray. That is called lateral displacement. And suppose the thickness of the glass slab is T, or width of the glass slab is T. So we can find the value of this D and T in terms of sine angle. In terms of sine angle, we can find the value of this D and T, but it will be given in the higher class. So we will see about this, how we will find the value of this lateral displacement and thickness T in higher class. Okay, students? So this is the refraction through a rectangular glass slab. Clear? Now in next class we will discuss about some numerical problem based on the refractive index. What? Refractive index. Refractive index. Okay, that is given by mu is equal to C by V. C is what? Speed of light in vacuum or in air, and V is speed of light in given medium. So in this way you can find the refractive index of the given medium. Suppose light is travel from air to glass, and speed of light is given. You know that speed of light in air or vacuum 3 to the power 8, and speed of light in glass suppose is given 2 into the power 8. 2 into 10 to the power 8 meter per second. 8 meter per second. So what is the refractive index of glass with respect to air? What? This is cancelled out 3 by 2 or 1.5. 1.5. And since mu is equal to the ratio of speed C by V, so it has no unit. It's have no unit because here speed of light is given, that is already measured in meter per second. Here speed of light is given medium, is given in given medium, so that is also in meter per second. So meter per second and meter per second. Meter per second. Both are cancelled out. So that's why the refractive index have no unit. Clear? So using this formula of refractive index C by V, we can calculate what? The value of refractive index. Means in either three quantity, mu is equal to C by V, in all three quantity, mu, refractive index, C speed of light in vacuum or air, and V speed of light in given medium. In all three quantity, any two is given, you can find the third one. Clear? So this is the overall idea about the reflections through a rectangular glass slab and how we can use this formula of refractive index, that is the ratio of speed of light in vacuum to the ratio of speed of light in given medium. Okay students, so you will try to solve the numerical problem based on this formula. Any doubt you can ask in next class. Okay, students, thank you. Have a nice day.
Refraction through a rectangular glass slab. Let us now perform an experiment and find out how light gets refracted when it is incident on a rectangular glass slab. Apparatus: a drawing board, rectangular glass slab, drawing pins, sheet of white paper, a protractor and sharply pointed pencil. Procedure: let us consider a drawing board with a sheet of white paper fixed with drawing pens. Keep the rectangular glass slab in the middle of the drawing sheet. Mark its boundary ABCD with a pencil. Remove the glass slab. Draw an incident ray IO on AB. Draw the normal at point of incidence NON dash. Fix two pins P and Q on the incident ray IO. Place the glass slab within its boundary ABCD. Looking from the other side of the glass slab, fix two pins R and S such that your eye and the feet of all the pins are in one straight line. Look through the glass slab along the plane of the paper from the side CD and move your head until the images of the two pins P and Q are seen clearly. Closing your one eye, adjust the position of your head in such a way that the images of the pins P and Q lie in the same straight line. Fix two pins R and S such a way that your eye and the feet of all the pins are in one straight line. Remove the slab and also the pins from the board and encircle the pinpricks on the paper with a sharp pencil. Join the position of tip of the pins P and Q and produce the line up to AB. Let PQ meet AB at O. Similarly, join the positions of tip of the pins R and S and produce it up to the edge CD. Let RS meet CD at O dash. join O dash. It is a refracted ray. Measure the angle of incidence, angle I, angle of refraction, angle R, and angle of emergence, angle E, respectively. Angle I greater than angle R, and angle I equals to angle E. Also produce PQ up to P, as shown by a dotted line. The emergent ray is parallel to the incident ray. The above experiment shows that when a ray light is passing from air to glass, from a rarer medium to a denser medium, the refracted ray bends towards the normal drawn at the point of incidence. In this case, angle I greater than angle R. When the ray of light is passing from glass to air, that is, from a denser medium to a rarer medium, the refracted ray bends away from the normal. In this case, angle R greater than angle I. The emergent ray, O-E, which is nothing but the refracted ray emerging out of the glass slab, is parallel to the incident ray. This means that the refracted ray, emergent ray, has been displaced from its original path by distance xy. This displacement is referred to as a lateral displacement. Now, you're familiar with the refraction of light. Refraction is due to change in the speed of light as it enters from one transparent medium to another. Experiments show that refraction of light occurs according to certain laws. The following are the laws of refraction of light. 1. The incident ray, the refracted ray, and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. 2. The ratio of sine of angle of incidence to the sine of angle of refraction is a constant for the light of a given color and for the given pair of media. This law is also known as Snell's law of refraction. If I is the angle of incidence and R is the angle of refraction, then sine I by sine R equals to constant. Equation 4. This constant value is called the refractive index of the second medium with respect to the first.